Okay. Now our purpose is to compute the partial derivative, second order partial derivative. So to compute the derivative, our equation is, the idea to compute the derivative is simply derivative the equation again and again. So our equation is fxz yz is 0. Therefore, to compute zxy, we first taken derivative with respect to x. So we have 0 is dx capital F xz yz. Then to compute this, apply the chain law. This will be f1, the derivative of f with respect to its first variable. Then multiply the derivative of the first variable to x plus f2 yz to x. Now, to compute this, we have to remember that z is a function of xy. So this will be f1. So z plus x zx. The red circle part is z plus x zx. Because the z, you have to consider the z as a function of x and y. Okay. Now similarly, the second term is f2 and yzx. Because x and y are independent variables, so the partial derivative of yz with respect to x is simply yzx. So this is the first derivative. Of course, from this equation, you can solve for zx equals something. But I will not carry out the computation here. Our purpose is to compute the second derivative. Okay. To the second derivative, we take the derivative of this equation again. So, but we take derivative with respect to y, because what we want is zxy. We already have zx here. We already have zx. We want zxy. We need to take derivative with respect to y. So we take a derivative with respect to y from this equation. We get 0 is dy, the right hand side, f1 z plus x zx plus f2 y zx. Okay, then apply the law of derivation. We get the partial derivative of this multiplication with respect to y. So firstly, we have f1 z plus x zx y plus z plus x zx and the partial derivative of f1 with respect to y. Okay, and for the second term is similar. The second term is f2 yzx with respect to y plus yzx, the partial derivative of f2 with respect to y. Okay, so we simplified this to get f1 zy plus x zxy. This part, z plus x zx, then derivative with respect to y, give us our deserved zxy. So this is why we take derivative with respect to y in this step, because we want to generalize zxy. Okay. Now, the next term is z plus xzx. When you compute the partial derivative of f1 with respect to y here, when you compute the partial derivative of f1 with respect to y here, you need to remember that f1 is also a composition of some function. f1 is the function. f1 is the function x, y, z maps to, maybe I have no space to write. f1 is the function in blue. x, y, z maps to x, z, y, z, then applied by f1. This f1 here is the composition of, as a function of x, y, z, is composition of these two functions. So to compute the derivative of f1 with respect to y, you need to apply the chain rule. Okay? Apply the chain rule, the derivative of f1 with respect to y would be the derivative of f1 with respect to its first variable, which we denote by f11. Then the first variable with respect to 1. The first variable is xz with respect to y. Okay? Then plus the derivative of f1 with respect to the second variable. The second variable is f, which we denote by f12. And then multiplying the derivative of the second variable with respect to y. That is yzy. We should have this. And for the f2, for the second line of the previous step, it is similar. So we plus f2 yzx derivative with respect to y is zx plus y zxy. Then plus yzx, and the derivative of f2 with respect to y is the same as the last step for f1 with respect to y, which is f21 xzy plus f22 yzy. We don't need to compute. We simply copy the previous computation here and replace the first sub-index of f. We have f11. We replace the first one by 2, and f12 replace the first one by 2. So we get this result. So you don't need to compute. You simply copy and modify the index. This is the trick to faster your computation. Now, in this expression, we have this derivative and this. You need to compute these two. So we go forward to get f1 zy plus x zxy plus z plus x zx, then f11 xzy plus f12 z plus yzy. Okay, you simply expand this term and this term by the product law. Okay, and then the second, for the f2, you need to write f2 zx plus yzxy plus, maybe I will change a color, blue, plus f2 zx plus yzxy plus yzx. Then this part you will not compute. You simply copy the previous line, but replace f11 by f21, f122, f22. You get f21 xzy plus f22 z plus yzy. So we obtain the equality 0 equal the last two lines of this page. From this equality, you can solve for zxy. You can solving this equation to get the partial derivative of zxy we want, and the result contains not only capital F and its derivative, but also x, y, z, and zx and zy. The result for the xy, the expression for the xy contains x, y, z, and capital F, the derivatives of the capital F, and also zx and zy. Also contains zx and zy. For the x we mentioned, we can using this equation to solve for the x. And similarly, by derivative with respect to y, here with respect to x here, if you take derivative with respect to y, you can obtain an equality involving zy, and you can solve for zy. So in conclusion, our zxy could be expressed by xyz and capital F and its derivatives. The zx and zy could be expressed by xyz and the derivative of capital F. Okay, so the computation could be continuous, and it is a long computation, but there is no new idea in the computation. But we will not perform the computation here. But once it is necessary to do the computation, I hope you know how to compute from our demonstration here. Okay.